This is our function, and we're going from 1 to 5, and we will be using n is equal to 4. Of course, it will be the same for both this. First thing first, we should compute the delta x whenever we have this information. Well, delta x is just going to be 5 minus 1, and then divided by the n value. So right here we have the 4, and all in all, we'll end up with 1. And this is telling us the width of the interval. So as you can see, if you go from 1 to 5, this is telling us each time we go up, it has to go up by 1. So we start with 1, and the next one will be 2, and then 3, 4, 5. And likewise, right here, it will be just 1, 2, 3, 4, 5. If the delta x is equal to 0.5, then we'll just have to go from 1, and then 1.5, and then 2, 2.5, and so on. Okay, so for the first picture, let's talk about how to compute m4 first. The midpoint rule when n is equal to 4. Well, let's look at the first interval from 1 to 2. We have to look at the middle x value. And that's, of course, right here. And the middle of 1 to 2 is just 1.5. And now let's see how to compute the area of the first rectangle. First, we need a base, which is just 1, because we go from 1 to 2, right? So we have 1. And yes, that's also the delta x. And we have to multiply by the height. To get the height, we have to use the 1.5 for the x value. What we do is, we start right here and we go up, hit the curve, and then we make a rectangle like this. So this is the first rectangle that we have. And for the height, well, we just have to plug in 1.5 into the function. That's the height. Let me just write this down right here for you guys. This is f of 1.5, like that. Okay? Well, we'll just have 1 times f of 1.5. That's the idea. And for the next one, okay, we'll see. The base right here is again 1. And let me just purposely write down the 1. I know 1 times anything, just that thing, but let me just write down the 1 again, okay? And we have to look at the middle of 2 to 3, which is just 2.5. And let me indicate that right here, 2.5. Well, to get the height, again, we have to plug in the middle point, which is 2.5 into the function, and just start right here, go up, hit the curve, and then you can draw your rectangle like this. So this right here is f of 2.5, and let me just put that down, f of 2.5. And you pretty much get the idea, huh? All right, now check this out. Everybody has the 1. Let me factor out the 1. I know this is redundant, but let me just do it, please, right? Well, the reason I want to factor out this one is because I want to emphasize this right here is the delta x, right? So again, everybody will have the delta x, so we can factor that out. And that's why this formula is like that. We have the delta x all the way in the front. Notice that we also have the bar, like the x1 bar. This right here is telling us the middle, right? The average between the first interval 1 and 2, which is 1.5. So that's the notation of that bar. But in my opinion, it's better if you just draw the picture and understand the geometry, and you'll be able to compute the area. So that's the idea. And let's also talk about the trapezoidal rule, because this right here is just pretty much an expression, and we'll just use a calculator for this right here, okay? But let's look at the trapezoidal rule when n is equal to 4. Well, this right here is equal to, we have to draw trapezoids now. To do this, we'll be using the endpoints of each interval. For this one, we'll be using 1. We go up, hit the curve, and likewise, we also go to 2. Go up, you draw this, and then you're going to connect the endpoints. So this is supposed to be a trapezoid, right? So again, here is the picture, much better picture. That's the idea. Now, how do we find the area of the trapezoid? Let me remind you. In this case, the area is just equal to height divided by 2 times b1 plus b2. But we can also draw the trapezoid like that. So in that case, this will be considered the base 1, base 2, and this right here is the h. So that's the idea, right? Anyway, this is not really the base, this is the height technically, but you know, just remember this idea. So what we need is the width right here technically, how long this is, which is again 1, and that's again the delta x. So for the area of the first trapezoid, we have to have the 1 and divided by 2. And then we are going to multiply by, well, this side and that side, we have to add them up. For this side, it's supposed to be f of 1. And notice that right here, we are using the 1. Earlier, we were using the middle of 1 and 2, so that's the 1.5. That's the x1 bar. This time, it's just f of 1. So that's the formula right here. Okay, so inside here, we have to do f of 1. So let me just put this down in red. Why not? Just all in red. F of 1, right? And then the next one, we are going to add it with the next base, which is this, which is just going to be when x is 2, plug into the the function. So we have f of 2, like that. So for this one, we have f of 2. So congratulations, this is the area of the first trapezoid. Then next one, of course, we have to add, I'm going to use green for this one. For the area of the next trapezoid, first, look at this right here, is of course 1. So we have the 1, and yes, that's the delta x, and then we divide it by 2. And then we multiply it by, well, in this case, we have to figure out how long this is, and then how long this is. So that's the picture, similar, okay. Okay, notice, for this right here, it's again f of 2, because the x value right here is 2. So we have the f of 2. And then for this right here, it's going to be f of 3. Now, we will just have to add f of 2 and f of 3 right here. And that's pretty much the idea. And of course, it will be the same for the rest of them. Now, as you can see, this expression is pretty long, but the good thing is that we can actually factor out the 1/2 because everybody has the 1/2. And when we do that, well, let's see what we have. Let me again emphasize the 1. So we have 1/2, right? Because this 1 is the delta x. That's the idea, right? And then right here, notice when we factor out the 1/2, of course, we'll have to just combine the like terms inside. For this parentheses, notice that we have f of 1, and this is just happening one time. And for the next one, notice that we have f of 2 right here, but we have to combine with another f of 2. So all in all, we have to add 2 of the f of 2. That's the idea. And as you can see, for the next one, we have f of 3 happening twice as well. So we just add 2 times f of 3. And then for the f of 4, well, it happens twice again. So we add 2 times f of 4. And the last one is f of 5. It's only happening one time. So we just add 1 f of 5 like this. So this will be the expression for T4. And hopefully that also explains the formula right here. Okay, here is the deal. I will show you guys how to enter all this onto the calculator now. First, you want to go to y equals, so you can enter the function. So let me just enter 1/2 x times cosine of x. And we add the 3 to that. And you don't have to graph this. This is what you have to do. Go back to the home page. And as you can see, the expression is 1 times f of 1.5. And we enter the function in y1, right? And this is how you are going to call out the y1. Go to farce, y farce, and then go to the first one, function, and you're going to choose the first one, y1. So this is pretty much our function f. And you are going to open the parentheses and enter 1.5. So this is equivalent to f of 1.5. And then we're just going to continue. Plus farce, y farce, function, and y1, parentheses 2.5. And that's pretty much the idea. So just keep doing this. And we have the next one is with 3.5 inside, and plus farce, y farce, function, y1, parentheses 4.5, close parentheses and another parentheses like this. And we get 8.9385. So this is for the midpoint rule. And now for the trapezoidal rule, we can just do 1/2, parentheses. For the f of 1, of course, we go to farce, y farce, function, y1, parentheses 1. And we need the next one is plus 2. And then farce, y farce, function, y1, parentheses 2, like this. And I think this is the easiest way to do all that on this calculator. So just kind of practice this and then get used to it. That will be my recommendation. And we have f of 4, so that's y1 of 4, of course. And for the last one, f of 5, we just do plus, and there's no 2 in front anymore, so vars, y vars function y1 parentheses 5. So close parentheses, and we are done. 9.2812. Okay, so these two right here are the approximations, but which one is actually better? Well, in that case, we need to use an integral, right? And now for the integral, we can just go to math, and we can go down to fnint. And as you can see, this calculator calls out the integral symbol right here. So we can just enter 1 to 5, and we can just enter the function right here again. But we enter the function as y1, so we can just do vars, y vars function, y1 parentheses x. Right? And then right here we need the dx like this. So that will be for the integral. So take a look with the M4, T4, and also the answer that we get from the TI-84. Which one is actually better? The answer is actually this. M4 is actually closer to the actual answer than T4. Well, if you want to be convinced, you can just go ahead, do the subtraction. This minus that, and compare this minus that. But I think it's pretty easy to see. This is off by 0.12-ish, right? And this is off by 0.2, right? Because this is 9.0, this is 9.2, right? So this right here is actually better. It might be surprising, right? Because the picture looks, okay, it's kind of wrong because you have a lot of sticking part. A lot of parts are sticking out. But the idea is that this part is being sticking out. We also have that part being missing. So maybe it's possible for us to take this part and fill that in. Well, so do not just judge a picture by its look.